Welcome to the deep dive. Today, we're taking a bit of a wrecking ball to traditional lesson planning. We're diving deep into project-based learning, PBL.
That's right. Specifically, how it can reshape math and science classrooms.
Yeah, and our main source here is this, well, fantastic toolkit from Heather Wolpert-Gawron. She's an award-winning teacher, Edutopia blogger. Really practical stuff.
And our mission today really is to give you the blueprint. We're pulling out the core philosophy, the, essential steps, the tools you need.
To mix and match tools?
Exactly. The tools you need to actually do PBL effectively. Think of it as a DIY guide if you're looking to design curriculum that really engages students.
Right. So this deep dive should give you that knowledge shortcut.
Hopefully.
The big idea, I guess, is trading those dusty textbooks for something focused on student innovation, creative problem solving.
That's the promise. But, okay, let's nail down the definition first. You said PBL is about identifying a real-world problem, finding a solution.
Yeah, but how's that different from, say, an old-school science fair project? What are we missing?
That's a really important question, because the simple definition kind of sells it short.
Okay.
The missing piece is the ongoing learning. And the integration of skills. PBL is the act of learning different subjects all at once, simultaneously.
Right. Not in silos.
Exactly. Students identify a real problem, could be local, could be global, and they develop a solution. But it has to be backed by, real research, evidence-based.
And crucially, they have to communicate that solution somehow.
Yes. They present it, often using multimedia, sort of 21st century tools. And the learning is shown throughout the journey.
Not just at the end.
Not just at the end. It's shown as they interact, collaborate, and this is key, as they assess themselves and each other along the way. It's a process, definitely not just a final product.
Okay, that makes sense. Process versus product. That leads perfectly into the why, doesn't it? Why does this actually work better than, the traditional ways?
Well, the sources use this great analogy I like.
The theme park one.
Yeah, Six Flags versus Disneyland one. Six Flags, lots of separate rides, disconnected lessons maybe. Disneyland immerses you. It's all one big story.
So PBL wraps the lessons in a story, a narrative about a problem that needs solving.
Precisely. And when you embed the content like that in a compelling story, PBL naturally hits those key skills for future success. The 4 C's people talk about.
Collaboration, communication, critical thinking, creativity.
Yeah. And it's not just buzzwords. The author gets really specific.
Oh, yeah, I saw that list. Questioning, research, writing, speaking, solving problems, working together, arguing constructively, analyzing.
Advocating, synthesizing. It's a heavy list. These are real marketable skills we're talking about.
They really are. And it connects to what A.J. Giuliani says about the modern workplace, right? That shift he talks about.
Traditional education often focuses on, what does he call them, algorithmic tasks.
Following instructions.
Yeah.
Down one path.
Exactly, like a computer might. But Giuliani argues, and the source material supports this, that PBL prepares kids for heuristic tasks.
Which means more trial and error.
Yeah, trial and error, creativity, dealing with new situations all the time, stuff that doesn't have a single set of instructions.
Okay, so if old school teaches you to follow the manual, PBL teaches you to write the manual. Or maybe design something completely new.
Kind of, yeah. It teaches them to be designers, innovators, adaptable thinkers. It's a different mindset.
That feels like a pretty critical shift. No wonder the students themselves seem to be big fans. I saw those quotes.
Oh, the students are the best experts on engagement, aren't they?
Yeah. Daniel said engagement comes from interactions with real-life dilemmas.
Right.
An opportunity to learn how to solve them. Something unforgettable.
And Natalie backed that up. She said, students just remember the material better than reading it from a textbook. It sticks.
So it's grounded in things like role-playing, real scenarios, authentic audiences.
And assessing multiple skills together, requiring research across different subjects, it makes the learning feel, well, necessary, not just something you have to do for a grade.
Okay, so the why is pretty compelling. But if it's supposed to be this Disneyland experience for the student, how does a teacher actually design all that? That seems like the hard part.
It does. The sources talk about this idea of a teacher's maker movement, where the teacher's product isn't just a lesson plan, it's an original unit.
I like that. Teachers as innovators.
Exactly. You have to give teachers the freedom to be innovative if you expect them to model it for students. And the design process they suggest, it's a bit counterintuitive.
How so?
It flips the usual model. You don't start with the standards.
Really? What's step 1 then?
Step 1, design toward what you love. Start with your own interests, or something you know the students are into. Maybe like brain research for a genius unit, something engaging.
Okay, I'm with you. Start with the cool idea, then what?
Then step 2, look back at the Common Core standards, or whatever standards you need to meet.
Hold on, isn't that backwards?
Yeah.
Like super risky?
Uh,
How do you make sure you cover everything if you start with the fun stuff?
That's step 3. Fill in the gaps. You take your cool thematic unit, compare it against the standards, and see what's missing.
I see.
Then you design smaller, targeted lessons just to cover those specific objectives you missed. The idea is that the passion drives engagement first.
Which makes the boring but necessary standards stick better later.
That's the theory. Passion makes learning stickier.
Okay, but the moment you ditch the textbook structure, organization feels like it could become a nightmare, right? Kids collaborating, researching weird topics, it could get messy fast.
That is definitely the big management challenge, and the answer the sources give is transparency and scaffolding.
Yeah.
You absolutely need checklists, or pacing guides, whatever you want to call them.
Checklists, why are they so critical?
Well, several reasons. They make sense of the big picture for the students. They force you, the teacher, to plan ahead. Big time.
Okay.
They communicate your intentions, the purpose, the pacing, really important for parents too. And they give students a tool for managing their own time, independent learning.
Is a checklist really better than, detailed instructions, paragraphs explaining everything?
According to one student, Joshua, absolutely. He said checklists are better because, quote, we can immediately see what we need to do and get straight to work.
Huh. Less reading, more doing.
Pretty much. You share the bones of the unit, the structure, and empower them to handle the workflow.
All right, let's get practical. The toolbox.
Yeah.
If students are doing these complex real-world projects, what specific, 21st century literacy tools do we have to teach them explicitly?
Yeah, you can't just assume they know this stuff. We
Yeah.
definitely need lessons in internet literacy.
Like how to Google better.
More than that, teaching the 6 steps of being an internet detective. Things like understanding URL extensions, what is .edu versus .gov versus .com tell you,
Yeah.
using Google Advanced Search properly.
Okay. What about the elephant in the room? Wikipedia. Still a no-go.
Not necessarily a no-go, but it has to be used wisely. That's what we teach. Use it as a starting point. To quickly grab keywords, dates, names, the basic facts, but then you have to verify every single piece of that information on multiple separate, reliable websites. It builds critical evaluation habits. Skepticism, almost.
Got it. So, okay, now we get into writing. These projects involve lab reports, engineering proposals, summaries, technical stuff. How do you structure that writing, especially if you're not an English teacher?
You need simple, portable templates they can use anywhere. For basic expository paragraphs, the author swears by QRF,
QRF.
question-response format. Basically, structure the paragraph around answering a question. Main topic sentence is the answer. Then evidence or proof. Then your commentary, your original thinking. Then a conclusion or transition.
So it forces them to justify their points with evidence.
Exactly. Justify and explain via writing, as the author puts it. Works across subjects.
Okay, what about bigger things, like a whole proposal?
For that, you might introduce something like BRAC. It's actually engineering nomenclature for executive summaries.
BIRAC. What's that stand for?
Background, issues, recommendations, analysis, and consequences. It gives them a professional structure for a persuasive pitch, making sure they hit all the key parts of the argument, not just the sentence-level stuff.
Makes sense. And since these are group projects,
Huh.
conflict is inevitable, right?
Mhm.
How do students manage that?
You get ahead of it. They create a collaboration constitution at the beginning.
A contract.
Yeah, written by the students themselves. It lists their expectations for each other, rules for communication, like how fast you need to reply to an email, and importantly, the steps they'll take if someone isn't pulling their weight.
Sets up a professional framework before problems start.
That's the idea.
Yeah.
Proactive teamwork management.
Okay, preparation covered. Now, grading. This seems like a huge hurdle for teachers doing PBL. You're grading the science, the math,
Yeah.
but also the communication. How do you assess the writing part quickly and effectively?
Yeah, speed is key. The author gives a couple of really practical tips. First, when giving feedback, especially early on, focus on only one skill at a time.
Just one.
Just one. So if you're teaching them how to embed data with a proper citation in a lab report, focus your feedback only on that. Ignore the run-on sentences for that round.
Why?
It avoids overwhelming the student with, a sea of red ink. It keeps the focus on mastering one specific new skill. Less intimidating, more effective.
Okay, that makes sense.
Yeah.
What about for faster grading overall?
Tip 2, Create a key of feedback symbols instead of writing out full sentences. A quick symbol for funky wording, another for run-on sentence.
Like a code?
Kind of. It saves you writing the same comment over and over. You can quickly mark the issues without spending 5 minutes crafting advice on something secondary to, say, the scientific accuracy. Keeps your time focused on the core content.
Smart. And the ultimate goal of all this scaffolding and assessment.
Well, there's this unit idea, the teach them to be teachers unit. The core idea there is that the highest level of understanding is actually the ability to teach.
Ah, interesting.
When students have to assess their peers using a rubric, they're forced to look at the material through a teacher's critical lens. It deepens their own understanding immensely.
Let's make this really concrete now. Can we walk through some of those unit examples, show how these tools actually get applied?
Absolutely. Let's start with a shorter one, the 2-week genius unit.
Okay, what's the mission there?
The big question is, what defines genius? Students role play as medical professionals. They do jigsaw activities, researching brain plasticity. The whole idea that IQ isn't fixed, it's dynamic.
Right, and the final product?
A formal scientific lab report. But here's the twist. It's written to a patient or their parents, informing them they might actually be a genius, citing all the research and evidence.
Oh, wow. So the audience makes the lab report feel really important, life-changing almost.
Exactly, not just another assignment.
Okay, next up, the theme park unit. This one sounds bigger, maybe a month long, and more math and engineering focused.
Definitely more rigorous on the STEM side. Students become theme park designers. Their task is to invent and design an entire themed land based on a specific scientist. Imagine like Teslaville or Curie Corner.
Huh, cool. What's the math involved?
Real math. They have to calculate cost analysis using the actual break-even formula, C equals mx plus b. They design structures like arches, calculate landscaping needs using area and perimeter. It's applied geometry and algebra.
And this is where those advanced writing structures fit in.
Perfectly. Their final pitch involves writing a persuasive business letter to potential investors. And that's paired with the executive summary using that bi-arc structure we talked about. Background, issues, recommendations.
Analysis, consequences.
That's right. So they have to write like real engineers or entrepreneurs persuading a skeptical audience.
Precisely. It's authentic communication for a high-stakes purpose.
Okay, finally the big one. The Galapagos Unit. This can run for a month or two. Yeah, this is a larger scale project. Students role play as scientists on an exploration team, and their mission is pretty heavy. Figure out which endangered species on the Galapagos they should prioritize saving.
Wow, okay. So lots of research?
Tons. Deep island research, lessons on biodiversity, and then a creative challenge. They have to invent a mythical, adapted species, like the author mentions a marine torguana.
Why do they do that?
To demonstrate they really understand evolutionary pressures and adaptation, it shows deep comprehension.
And the final product here, is it another paper?
It's an oral pitch. They have to present their case, which species to save and why, to a board from a major institute. Again, an authentic, demanding audience.
And they'd have backup materials, I assume.
Oh, yeah. They create a collaborative digital explorers journal documenting all their research findings and their final protection plan, including required funding and technology.
So the audience is real, the research is deep, the stakes feel incredibly high.
That's the goal. Real problems, real research, real communication.
Okay, wow. We've covered a ton of ground there. Philosophy, design steps, specific tools, grading hacks, even those detailed unit examples.
Yeah.
If we had to boil it all down, though, what's the single core idea, the main takeaway for someone listening?
I think it comes back to process over product. PBL has to involve real-world scenarios. It has to require using different kinds of reading and writing, and it absolutely must involve an authentic audience, someone beyond the teacher.
And that's all tied together by that mantra you mentioned from the source. If it doesn't exist outside of school,
then it isn't worthy enough to be taught within school. It sounds provocative, but it's about relevance.
Yeah, and making education about equipping students for life, not just for the next test.
Exactly. The author says education's job is not to always be there for the student, but to give them the skills to be their own source of education during their life, empowering them to learn forever.
That's a powerful thought to end on. So we'll leave you, the listener, with a challenge tying back to that highest level of understanding.
The ability to teach.
Right. If that's the peak, what specific piece of content, or maybe what skill from today's deep dive, do you now feel informed enough to teach someone else? What's the next lesson you're ready to design and deliver?
Something to think about.
Definitely. Until the next deep dive.